Welcome to Disha School Science. I am Tapan Sarma, present before you, trying to teach science for high school students. Today, I am here try to teach science lessons regarding chapter 1 activity related discussions, because it is seen that most of the students try to left activity in book whatever given, but this is an important part for exam, particularly MCQ is concerned, so we have to give more importance to this activity. যিসকল অসমীয়া মাধ্যমৰ বিদ্যালয়ত পঢ়ি আছে তেখেতসকলৰ বাবেও এই ভিডিঅ'টো উপযোগী হ'ব, আৰু যিসকল অসমীয়া মাধ্যমত পঢ়ি থকা ছাত্ৰ ছাত্ৰীয়ে ক্লাছ 11 ক্লাছ 12ত ইংলিছ মিডিয়ামত পঢ়িব বিচাৰে তেখেতসকলৰ কাৰণেও এই ভিডিঅ'টো উপযোগী হ'ব, কিয়নো মই যি ইংলিছ লেংগুৱেজ ব্যৱহাৰ কৰি আছোঁ সেইটো একেবাৰে চিম্পল, সহজে বুজিব পাৰি। সেইকাৰণে এই ভিডিঅ'টো যেন চাই। Let's start my part 3 discussion related to activity chapter 1 chemical reaction and equation. So in our activity number 1, if you see activity number 1.1, it is very simple activity given. Simply you see a magnesium ribbon is taken. What is the color of magnesium ribbon? You know, that is silvery white, and this is burned with the help of burner, and whatever the ash produced, that is collected in watch glass. Can you name the product form in watch glass? That is magnesium oxide. Okay, so it is very simple. Regarding this chemical equation involved, here you see whenever magnesium burned, it get mixed with oxygen present in the air and forming magnesium oxide. If we balance it, 2 here, 2 here. Okay, now what question asked? You see, what do you observe? So what will be the answer? We observe that whenever magnesium burns, then magnesium oxide produced as S, and what is the color of this magnesium oxide? That is white. Okay, so this is activity 1.1. Based on this activity, I want to put one question to you. Okay, so you see activity 1.1, I put one question to you. Try to answer the questions and send to me. I can evaluate your answer. You see activity 1.1, what happens when magnesium is burned in air. So your answer you have to write like this way. Act 1.1 answer simply you put. Okay. So this is about activity number 1.1. Now come to this next activity 1.2. Here this activity we come back again whenever we discuss about displacement, double displacement reactions. Okay, we start activity 1.3. In this activity you see that picture given here. This is a conical flux. Okay, here we have to take some zinc granules. Okay, so what is the color of this zinc granule? You know, it is somewhat bluish white or silvery gray. We have to put zinc granule in this conical flux. After that, slowly we have to put dilute sulfuric acid and stop the mouth with the help of cork. Through this cork we have to insert one glass tube. Okay, this is the setup. So what will happen after, whenever we add this dilute sulfuric acid, then reaction will happen. So what is the reaction involved? You see, I have written here zinc Zn plus H2SO4 sulfuric acid. Then what will form? Zinc sulfate and hydrogen gas. Okay, so hydrogen gas evolve. So question, what question asks? You see, what question asks? Do you observe anything happening around the zinc granules? So you see this around the zinc granules. Yes, what is happening around the zinc granules? Bubbles of hydrogen gas around zinc granules happen. Okay, that means zinc granules appear to be bubbling and the solution become slightly cloudy due to the formation of zinc sulfate. So your answer is, do you observe anything happen around the zinc granules? Bubbles of hydrogen gas appear and the solution become slightly cloudy. Next question asks, touch the conical flux or test tube. Is there any change in temperature? So this question you see, is there any change in temperature? Yes, temperature rises. Whenever we touch this conical flux with our hand, we feel somewhat hot. Temperature rises. So what type of reaction it is? Exothermic or endothermic reaction? Definitely this reaction is exothermic reaction. So based on this activity 1.3, I asked one questions. You see, activity 1.3, how can you test the presence of H2 gas in this reaction? You try to answer the questions and send to me. Okay, so next activity 1.4. Activity 1.4. Okay, so this is very simple activity. What you have to take, you see, in a beaker we have to take few crystals of calcium oxide. What is the common name of calcium oxide? That is called quicklime. Here we have to put. After that, we have to put water slowly. Okay, so definitely chemical reaction will happen whenever we add water in calcium oxide. So the reaction is given here. You see, calcium oxide react with water produce calcium hydroxide along with evolution of heat, and this calcium hydroxide what is called slackline. Okay, so one question asks here, do you feel any change in temperature? This question asks, do you feel any change in temperature? Yes, there is. Whenever we touch with our hand, we feel something hot. That means heat evolve. And what type of reaction it is then? Definitely it is an exothermic reaction. Okay, so next one question I ask to you, try to give the answer of these questions. Give one example of chemical reaction other than activity 1.4, which is an exothermic reaction. Try to give this answer in short and send to me. Okay. Next, coming to activity 1.5. 1.5. What this activity you see? Take about 2 gram ferrous sulfate crystal in a dry boiling tube. That picture given here. In this test tube, we have to take 2 gram ferrous sulfate. And you know what is the color of this ferrous sulfate? You know, that is green color. And this ferrous sulfate we have to give heat with the help of burner. Okay, so whenever we heat it, then what will happen? These reactions given, you see, whenever we heat this ferrous sulfate, then decomposition start forming 3 products: ferric oxide, sulfur dioxide, sulfur trioxide. Okay, now based on this question asks, you see, note the color of the ferrous sulfate crystal. This color of the ferrous sulfate crystal. So what will be the color of this ferrous sulfate crystal? As I already told you, green color. Okay, next, observe the color of the crystal after heating. Observe the color of the crystal after heating. That will be bluish green. Okay, so based on this activity I put one questions to you and try to answer it. I put here 2 questions. Try to answer it. A number, what happens when ferrous sulfate is heated? You try to answer it. B number question, write the valency of sulfur in sulfur dioxide and sulfur trioxide. Your answer send to me. Okay, next, coming to this activity 1.6. Activity 1.6. This is also very simple activity. Take about 2 gram lead nitrate powder in a boiling tube. Here picture given. You see, here we have to take 2 gram lead nitrate in a test tube and heat with the help of burner. Okay, so what will happen whenever we heat? Then this lead nitrate decompose, forming some gas called fumes. So what is the color of this fume? You see, this color of the fumes will be brown. That brown. What question asks here? You see, what do you observe? What do you observe? Note down the sense, if any. So what do you observe? We observe that brown fumes produce emission of brown fumes, already given here. Okay, and why these brown fumes occur? Actually, this is nitrogen dioxide. What is the reaction involved? Given next page. You see this reaction given next page. Whenever this lead nitrate is heated, lead oxide, nitrogen dioxide and oxygen gas evolve. Because of the production of nitrogen dioxide, the fumes become brown in color. Okay, so based on this, I want to put one question to you. You see, activity 1.6, try to answer it. Write to thermal decomposition reaction in the form of balanced chemical equation. That is your questions, try to answer it. Okay, now come to this activity 1.7. This activity is very important. You see, that is called electrolysis of water. How to electrolyze water? We have to take a plastic mug. We have to make 2 holes at the bottom and we should insert 2 carbon electrode. Okay, and fix it with the help of rubber stopper. Okay, then it will be connected to the battery and 2 inverted test tube filled completely with water to be added, to be inserted here. Now here we have to take water in this. We pour some water here. One important note is that we have to mix few drops of dilute sulfuric acid in water. Okay, now on the switch, then breakdown of waters occur, decomposition of water occurs. The reaction involved, you see, H2O, arrow mark, upper side electricity. Then what will happen? Hydrogen and oxygen gas produced, and we balance it 2 here, 2 here. Okay, now based on this, it is seen that the amount of hydrogen is double of amount of oxygen. Okay, based on this, some questions asked here. You see, what happens in his case? What happened in his case? So in his case means 2 electrodes are taken. Okay, so in this anode side, positive side of the battery, oxygen gas evolved by displacing water. On the other hand, this at the cathode side, negative side of the battery, hydrogen gas evolved. Okay, and if you see the amount of hydrogen gas is double the amount of oxygen gas. Okay, so second, which gas is present in his test tube? As I already told you, hydrogen gas and oxygen gas. Okay, so based on this activity 1.7, I put one questions to you. Try to answer it. Very important. Why should we add few drops of dilute sulfuric acid in water to carry out this activity? Important. This is very important. Dilute sulfuric acid, why should we put in water? Okay. Next is activity 1.7. Very simple activity. Take about 2 gram silver chloride in a cyanide dish. Here picture given. In this cyanide dish we have to take 2 gram silver chloride. Okay. What is the color of this silver chloride? The color of the silver chloride is, you see, what is its color? Shiny white. Shiny white. And we have to place this cyanide dish under sunlight. Under sunlight we have to place it. After some time, what will you observe? You see, observe the color of the silver chloride after some time. So after some time, when you observe, then it is found that this silver chloride turns gray color. Okay, so this is activity and the reaction involved given here. Silver chloride turns to silver and chlorine under sunlight. Okay, next activity 1.9. Okay, so this activity 1.9, we have to take 3 iron nails. Okay, that is important. 3 iron nails. Here what will be the setup? You see, in this test tube we have to take copper sulfate solution. Copper sulfate. What is the color of this copper sulfate solution? Blue color. Okay, and we have to dip this 2 nail. Out of this 3 nail, 2 nail we have to dip like this way and make this setup like this way. Okay, what will happen? Definitely a reactions happen. So what is the reaction involved? You see, what is the reaction involved? The reaction is given here. Whenever iron nails, that means iron react with copper sulfate, ferrous sulfate and copper reduced. Okay, so if you see the setup, this is 2 iron nails. After dipping in copper sulfate solution, the color is like this way after some time, and whatever the 3rd iron nails, that color remain as it is. Okay, there is a color difference. And if you see the test tube, before immersing this, dipping this iron nails, the color of this copper sulfate blue, and after dipping this iron nails, here the color of the solutions, so this blue color fade up. Very light blue color will be very light. Okay, So this is the activity 1.9. Now come to this 1.10 activity. Activity 1.10. In this activity, you see, we have to take 3 ml sodium sulfate solution and 3 ml barium chloride solution. How you see, in one test tube we have to take 3 ml barium chloride solution and another test tube we have to take 3 ml sodium sulfate solution. Now pour this sodium sulfate solution to barium chloride solution. That means we mix it both. You can mix like this also, like this also. Okay. So chemical reactions happen. The chemical reaction given here: sodium sulfate, barium chloride, barium sulfate, sodium chloride. So that is double displacement reactions. Okay. That means sodium displaces barium and barium displaces sodium, both. That means there is transfer of ions. Ultimately barium sulfate and sodium chloride form. So out of this barium sulfate and sodium chloride, if you see barium sulfate as given, that means it is in solid form. Okay. So it will be precipitated, it will be deposited at the bottom of this glass tube, test tube. Okay. So what will be the color? It will be somewhat white solid form, like a milky solid, milky solid form. And you get confused between which will be precipitated. You see, compared to barium, sodium is more active metal, so sodium chloride will be in the salt solution. On the other hand, less active metal barium sulfate will be deposited. Okay, so it will be deposited, and that is why this is called precipitation reaction also. Already we discussed in part 2 different types of reactions. Now, as I already told you, this activity 1.2 will come back whenever we discuss its double displacement reactions. Again given here, you see, recall activity 1.2. So here what you have to take, lead nitrate and potassium iodide, we mix it. Whenever lead nitrate and potassium iodide mix it, then the reactions happen. Okay. So what was the color of the precipitate form? Precipitate, you know this, first of all you have to know the reaction involved. You see, lead nitrate react with potassium iodide forming lead iodide and potassium nitrate. Okay. So lead and potassium is more active metal, so that will be in the solution. And lead iodide, lead is less active than potassium, so that will be precipitated in the solid form at the bottom of the vessel. Okay. So question is, what was the color of the precipitate form? That will be bright yellow. Can you name the compound precipitated? The compound is lead iodide. Okay. Write the balanced chemical equation for these reactions as I already given here. Okay. Is this also a double displacement reaction? Definitely yes. Double displacement reaction. Okay. So now come to this activity 1.11. So here what you have to do, what you have to do? We have to take a cyanidis. Now we come to this activity 1.11. Here what you have to take? In a cyanidis, we have to take copper powder, okay, and we have to heat it with the help of burner, okay. So whenever we heat copper powder, then oxidation reactions happen. You see, copper react with oxygen, okay, copper oxide form. So this is oxidation reaction. Copper transformed to copper oxide, okay. Question asks, what do you observe? We observe that this, whenever we burn this copper powder, then this copper powder become black. Copper powder become black, okay. So that's all this activity related topics. So if you like this my video, you subscribe the channel and press the bell icon so that continuous notification you will get. Thank you.